In this discussion, we're going to cover some introductory information about the periodic table. Okay, the first thing you should know is that there were lots of people that worked on coming up with a way to arrange the elements. It was pretty easy to keep track of when we had discovered 2, 3, 4, 10, but when those numbers started increasing, what they really wanted to do was to come up with some way to arrange them, some way to make a table where the position of the element on the table told you something about its properties. Kind of like, you go into a record store and the CDs are all kind of grouped based on the genre of the music. And so if a CD is in the rap section, that there are certain characteristics that music is going to have, or if it's in the country section, there are other characteristics that music is going to have. And so the periodic table is sort of like that. It's a way of obtaining information about the elements without having to look up all the details. That there are things that we can know by virtue of where it is on the periodic table. The man who's given credit for the beginnings of our periodic table that we use today is Mendeleev. And basically what he found was, when he arranged the elements in order of atomic masses, that there were, with a few exceptions, there were some trends that he could see, and that the way that the properties changed across the rows, it kind of repeated itself, hence the name periodic. And so his design worked, and not only that, he had some blanks that he had to leave in the table to make everything work, and he predicted what the properties would be of an element that would fit in that spot when it was discovered, and he did this with some accuracy, so that kind of reinforced the validity of his arrangement. There were a few elements, though, that did not quite follow the patterns, and he had to kind of flip them. So they weren't truly arranged in order of atomic mass. And if you look at the table that we use today, you'll see that not in every case is the mass increasing as we go across a row on the periodic table. But in his day, they didn't know about subatomic particles. And we're going to talk a little more about that later. But basically, once they knew about protons, a guy named Moseley arranged the elements, or found that when the elements were arranged in order of increasing number of protons, or atomic number, that's the number of protons in the atom, then that actually worked. You still had Mendeleev's arrangement, but now we didn't have any of them that were flipped in order to keep them in the right place in the table. Okay, so here is a typical periodic table, and let's look at a couple of things that you should note. Some of these things we're going to use right away, and others we'll kind of come back to later. But two terms, atomic number. All right, these are in most periodic tables listed above the element symbol. All right. Oh, how did I get that? Let's give us back to our red. All right. So here we have atomic numbers, which again, that's the number of protons in the element, which is the thing that identifies the element, is the number of protons. So that's the atomic number. And then the average atomic mass is this number that is below our element symbol. All right, so these are all average atomic masses. And we will, in the next unit, look at, well, how do they come up with these average masses, and why do you even need an average mass if it's the same element? Okay, this is just showing you some different arrangements of the periodic table. But one thing that you'll notice is that on a typical periodic table, I'm trying to see, this one's quite small, but if you look right in here, okay, you will notice that the atomic numbers jump 57 to 72, okay, and then, but if you look down here, the top row of this little block that's pulled out is 58 to 71. So essentially, this top row here should be inserted right in there, and then the second row here is inserted in this little area right here. And basically, as you can imagine, if we actually printed these tables with that stuck in there, it would just not be, it wouldn't fit on the paper as well, okay? And also, we have, as we'll see when we get to electron configurations, there are some special reasons why this can be pulled out that way, and then we'll talk about like the names for these elements that are down here. But just realize that this little block that's down here at the bottom of most periodic tables is actually meant to be inserted in the last two rows there. Okay, in general, we have metals and nonmetals on the periodic table. All right, the majority of elements are metals, okay, and they are on the left side of the periodic table. And then over on the right side here, we have nonmetals. Okay, and then we have a stair-step line that separates the two. Okay, and these we call metalloids. Alright, so what do things that are metals have in common? Well, all of these elements that we deem metals have certain characteristics. They tend to conduct electricity well. They tend to conduct heat well. They are shiny in appearance, have a luster. They are malleable. Okay, for the most part. That means that if you pound them with a hammer, they will flatten out into a flat sheet. They are also ductile, which means they can be drawn into a thin wire. Nonmetals, on the other hand, are not lustrous. They tend to be brittle as solids. They're not good conductors. So kind of the opposite of metals. Metals tend to be solids at room temperature, with the exception of an element that you should be familiar with, which is mercury. Mercury is a liquid at room temperature. Nonmetals, on the other hand, can be solids, liquids, and gases at room temperature. Oh, back to the metalloids. The metalloids, these are elements that can have a combination of properties. So they'll have some properties that are metal-like, some properties that have more in common with nonmetals. An example would be it might be lustrous, but not a good conductor. It might be brittle as a solid, but conduct electricity. So a combination of properties. They're not really characteristically metals, not really characteristically nonmetals. So basically, it varies from textbook to textbook as to what they call metalloids. But for this class, I just want you to consider everything that touches this stair step, with the exception of aluminum, to be a metalloid. Aluminum is considered a metal, okay, but let's just call everything else that touches that stair step, we're going to consider it a metalloid. And just be aware that you may see different reference books that, especially the ones on the top and bottom end, there may be some difference of opinion as to whether they call them metalloids or not. The other thing to be aware of is we have up here the element hydrogen. And hydrogen behaves kind of in its own way. And so we really don't characterize hydrogen. It's on, of course, it's on the left side of the table, but it's a gas at room temperature. It kind of has its own unique characteristics, and so we really don't classify it typically as a metal or as a non-metal. So it's sort of kind of does its own thing. Okay, and here is a thing again showing you physical states at room temperature, and the periodic table in my room is also color-coded in this manner. And here again, this is showing us again the information metals, non-metals. Now see here, this is calling hydrogen a non-metal, and right now we aren't going to go into the details about its chemical behavior and why we might consider it both. But just be aware, some of these things, depending on what reference you look at, there may be more than one way of characterizing these. Okay, metallic character. This is just kind of showing you the trends, and one of the things we want to start getting used to is the fact that there are trends in behavior or characteristics of these elements as you move across a row on a periodic table or down a column. And one of these, metallic character. So metallic character is going to increase as we go down a group or a column, and it's going to decrease as we go across a row. And again, a little later we'll get kind of more involved in this particular trend. Okay, here's another way of separating the periodic table. We have our what we call our representative group or main group elements. So these are all of these on the two sides. Once we get into talking about electron configurations, this layout of the periodic table will have even more meaning for you. In the middle of the periodic table, these are transition metals. And then these groups down here, these are the rare earth elements, the lanthanides and the actinides. Okay, here's some new terms. Periods. A period is a horizontal row on the periodic table. So the second row is the second period. And then families. These are families, or the other word they use for this is a group. And these are the vertical columns on the periodic table. And as we're going to see, some of these columns have names. These families have names. And the reason for that is that one of the neat things about the periodic table is all of the elements that are in the same group or family have similar characteristics. Again, when we start discussing electrons, you're going to see why that is that they would have similar characteristics. But we'll look at a couple of these. Here's our notable families. The first family or first group is the alkali metals. And then the second group is alkaline earth metals. Then we have our transition metals in the middle. And the other ones I wanted you to be familiar with are halogens and noble gases. Okay, you'll be, as part of the periodic table project, you'll be looking up some of the common characteristics of these groups. So you'll be able to see that indeed elements that are in the same family do share certain